Hello everyone, I am Shekhar sir from Empower Tutorials. Today we will have some introduction about the topic that is called as complex numbers. As you know already, in 10th standard you have studied the quadratic equation supposed to be ax square plus bx plus c equal to 0. Then you are having the degree 2. You will have two roots of the equation. So x is equal to minus b plus or minus under root of b square minus 4ac upon 2a, and the roots that you take as real only. What do you mean by real roots that you are taking? Means whatever you are having under root b square minus 4ac, that you are taking as positive. In further, if you take here, this is negative, then the roots are imaginary, and that comes under the topic, you can say, complex number. So if you take the root of b square minus 4ac, which is less than 0, it means b square minus 4ac by squaring, still you can say less than 0, which is negative. And negative of square root, that comes the idea complex number. Now complex number simply is nothing but I, which is called as a complex number, and whose value that you are taking as root minus 1. Root minus 1. So if I say 4i, it is nothing but 4 into root minus 1, which you can say as root of minus 16. 5i, if I take, I can say it is 5 into root of minus 1. When the 5 goes inside the root, you can say it is minus 25, like that. So whatever you are having quadratic equation b square minus 4c, if it becomes negative, then you can convert this into a number which is complex number. Now a complex number having meaning on Cartesian coordinates. You know this is x-axis positive. You know this is negative x-axis. You know this is negative y-axis. This is positive y-axis. Now instead of this, I can have here as a plus I, which is positive imaginary axis, and negative imaginary axis, to plot, to draw a complex vector. Now here if I take a point A, whose x coordinate supposed to be A, and y coordinate is definitely plus B, which we normally take as A comma B. Then I can write, if I take this as a complex axis, I can write here Z1 bar, which is equal to real part A plus imaginary part, which is IB. This is plus B, but I am associating with I because this is associated with the imaginary axis, that is plus I and minus I. So Z1 bar is equal to A plus IB, and this is nothing but this vector that you can see here, Z1 bar. Similarly, I can write Z2 bar, which I can take here. Suppose here again I am taking A, but which is minus A, and this I will take as plus B. Then this is the coordinate minus A comma B. Then what is real part now? It is negative real axis minus A plus IB. Third, I can draw still like this, and this I say A, but this is now minus, and this is downward, so it is again minus B. I can say this is my Z2 bar. Z3 bar, you will understand that both are negative, minus A minus IB. And last, of course, you can take here if you want. This is my Z4. Then this is plus A comma minus B. I will write Z4 bar is equal to A minus IB. So Z1, Z2, Z3, Z4 are called as complex number. A complex number having two parts. One is called as real part, second is called as imaginary part. And you can write as a vector Z1 bar A plus IB, Z2 bar minus A plus IB, Z3 bar minus A minus IB, and Z4 bar plus A minus IB. So this is regarding the complex number, and this is also called as a Cartesian coordinate form or Cartesian form, or it is also called as rectangular form, which is having two parts. One is real part, second is imaginary part. Now here you can represent Z1 bar in different form also, which is called as a polar form. Now what is meant by polar form? Very easy. It is nothing but what? The angle made with the positive real axis and the magnitude of Z1. So I can say Z1 bar, which is equal to mod of Z1 angle theta 1, which is positive here. A mod of Z1 you can say, which is equal to nothing but what? If you take a Pythagoras, this is A, this is B, this is under root of A square plus B square, angle theta 1. Similarly, you can write for the polar forms of Z2, Z3, Z4 like that. Now, if you have two complex numbers, we will see the algebra of complex numbers for definitely up to two stage only, that is two basic operations. You know, arithmetic operations are addition, then you are having a subtraction, then you are having a multiplication, and the fourth one, that is division. All operations that you are doing, you can do with the complex numbers. Now first today we will see only these two. Next time, in next session we will see these two. Now for addition of complex numbers, let Z1 is equal to A plus JB. Sorry, not JB, IB. And Z2 is equal to C plus IB. I want resultant because this is a vector, this is also vector. Then Z1 bar plus Z2 bar. I want in rectangular form. Of course, Cartesian form, you have to add A plus IB plus C plus ID. Then when you add the two vectors, you will have addition of real parts. So it will be the real part of A Z1 bar plus Z2 bar will be A plus B plus I. The imaginary part is addition of two imaginary parts B plus D. So simple. So when I am having a first vector Z1 bar, which is A plus IB, and Z2 bar is C plus ID, which is in the Cartesian form, then Z1 bar plus Z2 bar, that is equal to A plus IB plus C plus ID, and that is taken as A plus C plus I plus D. Now you can guess for second operation, that is subtraction, it is Z1 bar is A plus IB and Z2 bar is also equal to C plus ID. Then what is the subtraction? Resultant will be Z1 bar minus Z2 bar, which is what is Z1 bar? Is A plus IB minus of C plus ID, which I can write as A plus IB minus C minus ID, which I can write as A minus C in subtracting from the first real part to second real part, and subtracting, I am taking I constant, B minus D. I is taken common, B minus D is the subtraction of imaginary parts. So resultant will be subtraction of real part and subtraction of imaginary part. Here very important thing is that when you are doing the operations on complex numbers for addition and subtraction, you have to take always Cartesian forms. You cannot do the operation of addition and subtraction with the help of polar form. No, polar form that we are using for multiplication and division, that we will see in the next session. I think that you have understood the concept of complex number, and I request you to have the share, subscribe and like our YouTube channel. Thank you very much.